Hello everyone, welcome to this channel again. So this is our third session of system design knowledge. So in this video, we are going to talk about the non-functional characteristics of a system. Okay, so first, what is non-functional characteristics? So in contrast, there must be a functional characteristics of system, right? So basically for system design, let's say I want you to design a TikTok app. Functional characteristics means the functions of the system that you must achieve or must implement, right? So for example, the video recommendation feature is a functional characteristic you must implement, or some e-commerce feature you must implement, right? So all these are functional characteristics of the system, which means the functions that make the whole system work as designed, right? Okay, on the other hand, non-functional characteristics means, these things doesn't directly affect the functions of the system. So basically, there are three non-functional characteristics of system which you hear a lot, I believe. So the first one is called availability. Okay. The second one is called scalability. And the last one is called reliability. Okay, so these are the three non-functional characteristics of a system. So basically, for example, when you design a system, after you give the functional features of a system, then, for example, in an interview or something, you must also give the non-functional characteristics of the system. And basically, for all system designs, mostly it's these three things: availability, scalability, and reliability. Okay, so now let's talk about each of them. What do they mean? How can we achieve availability, scalability, and reliability? What are the common patterns that are usually used in a system design? Okay, so first let's talk about availability. Okay, so what is availability? Availability, from the word you can guess, availability means the system should be available, right? So for example, when you open the TikTok app, you must be able to see the recommended videos. You must be able to see the video feed, right? So this means available of the system, right? If someday you opened it and now you see an error, which means, server has errors, now we cannot recommend videos to you, then the system is called unavailable, right? So when you design a system, availability means you must have a high availability for the system, which means most of the time your system should be online so users can use the actual functions of the system, right? So how do we evaluate the availability? So usually we evaluate the system as the percentage of online time. So let's write this down. It as percentage of the system's online time. So for example, if a system or if an app claims, my availability is 99, let's say. Example, okay, so let's say a system claims, my availability is 99.99%. So this means in 99.999% of the time, my system will be online. So in other words, let's say if my system runs 10K hours, okay, only 1 hour at most, my system can go down, okay, which means you cannot use my service at all. So this is the percentage which is used to evaluate availability. And when you see 99.999, another common name you hear about this is 5 nines, because there are 5 9 digits in it, right? Okay, cool. So this is how we evaluate availability. So one question you may ask is why there could be availability issue. In other words, why my system could have unavailable state. Okay, so there could be multiple reasons. Okay, cool. Why my system could be unavailable. Okay, so there are multiple reasons. So first is software bugs. Okay, so for example, maybe you're writing the video recommendation feature for the TikTok app. However, there is some bug in your code which causes system crash. Okay, so for example, your app or your code throws some exception. Okay, so for example, you divide some numbers by 0, or you access an unavailable memory. Okay, so this is a bug which will throw exceptions. And let's assume your system doesn't have a good mechanism to catch the exceptions and handle the exceptions. Then the unhandled exception will just crash your process, right? Which means your system will go down. So when people connect to your app server, because your system goes down, they will see errors, right? So then this is system unavailable, right? Another common reason for system unavailability is the hardware bug, hardware fault. Okay, so for example, maybe there is power failure, or there is some memory issues, or the disk has some errors. Okay, in these cases there will be also exceptions, right? And then the system will also go down. So this is another kind of reason which can cause unavailability of your system, right? But also there are some other reasons, right? So for example, maybe you hear about some story several years ago about one Amazon engineer, when he did some system job, he overwrites or deleted some system database data, right? So this is not caused by software bug or hardware fault. It's because the engineer did something wrong, right? He overwrite or he deleted something he is not supposed to delete, right? So this kind of errors are called by human errors, right? So it's actual human causing this kind of system unavailable. Okay, so these are the 3 main reasons which usually cause system unavailable, right? Okay, maybe another one is I believe you see it in some software, right? Which is planned maintenance. Okay, so let's say you open a software, it has a banner or it has a interstitial said, our system is in maintenance mode. Currently, please come back next morning at 8 a.m. or something, right? So this is planned maintenance. This is not error, right? But it's planned unavailable of the system, right? Okay, so these are the several reasons I can think of which can cause availability issues for a system, right? So the next thing is, okay, so let me put this away and let me write this down. So first we talked about how to evaluate, right, availability. Second, we talked about the reasons, the causes of availabilities, right? So how can we resolve? So let's see the resolution. Okay, how can we resolve system availability issues, right? So basically, I think in the first session we talked about the different architectures, right? The first architecture is about monolithic architecture, where you put all the codes and deploy them on a single machine, right? So if you use a single machine, definitely when there's something wrong with this machine, for example, software exception or hardware fault, then the whole system will go down. People cannot connect to your app server, right? So this definitely causes unavailable, right? So in order to achieve high availability, you must use multiple machines. Okay, you cannot only use a single machine, right? When I say machine here, it could either be a actual physical machine or it could be virtual machine, right? So I will not go into details of these two machines, but yeah, you can understand. You must use multiple machines, right? So in session 1, we talked about the two architectures. The other architecture is the microservices, right? So if we go to the first session here, yeah, this is the microservice architecture, right? So here you can see, by nature, microservice is already using multiple machines, right? Because different features are deployed on different machines. They have their own cluster maybe, and so by nature it already resolves the availability issues, right? So for example, let's say e-commerce feature has some bug. It causes the machines crashes for e-commerce feature. But the system, your whole app, for example, the TikTok app, it will still be available. It will still be online because the user, yes, they cannot use e-commerce feature anymore, but they can still connect to your app server. They can still see the recommended videos. They can still chat with other people, right? So in this case, your system is still available, right? So if you use microservice architecture, by nature, your system already have a high availability, right? So now, okay, let's go back to our session here. So resolution 1 is microservice architecture, right? Okay. So another question is that, oh, what if I want to have a high availability even for each service, right? So for example, in the architecture here, let's say even for the video recommendation feed or even for the e-commerce feature, for each feature, I also want it to be always available. So let's say e-commerce feature will never go down, or the availability for e-commerce feature should always be 5 nines, which is 99.99%, okay? And or more importantly, I think the video recommendation feed definitely needs to always be online, right? So if I also want each feature to have a high availability, what should we do? Similarly, you should still use multiple machines, right, to host the service or host the feature, right? Okay. So let's write this down. So similarly, you also need to use multiple machines to host the service or feature, right? So how to use multiple machines to host the service and feature, right? So in this case, actually, there are two common patterns, okay? So the first pattern is called active passive pattern or mode, okay? So what does this mean? This means, yes, you use multiple machines, right? So let's say, oh, here you have machine A, okay? And you also have machine B, and you also have machine C, okay? So you use 3 machines to accept all the requests from the users, from the app. Okay, so all these three machines can accept request. They can serve at the same time, right? But also you have some other standby machines, for example, machine D and machine E. Okay, so in this case, these two machines, they are in standby mode. Okay, so let's say, okay, okay, so these are active machines and these are standby machines. Okay, what does it mean? It means these three machines, they will serve all the requests from your app or from your clients or from any other services, right? But these two machines, they just stand by. They do nothing. Okay, they just stand by here. So let's say at some time, okay, so your system goes down. So let's say machine C has some problem and now machine C goes down. Then in this case, machine C goes down. So but you have one standby machine which could be used to serve requests, right? So in this case, you just pull in machine D and let it work together with machine A and machine B to serve all the requests, right? So this is called active passive mode, or you can say it's active standby mode. Okay, so another mode is called active mode. What does it mean? So in this pattern or in this mode, let's say you still have these three machines, okay, to serve the request. Okay, so you still have three machines to serve all the requests from users at the same time. However, even your system goes down. So let's say even machine C goes down at some point, the system can still go on to work. So machine A and machine B can still continue to work. Okay, so you may ask, oh, that's weird. If machine C goes down, how can the system still continue to work with machine A and machine B? Okay, so there are multiple techniques to achieve this. Okay, so first you can consider replication, right? Replication means that machine A, machine B, and machine C have exact same data. Okay, so let's say you are writing some data. Let's say I added a friend. Okay, so this information must be stored in your system, right? So you must write this information to your system. So in this case, you write your friend data at the same time to all the three machines. So all the three machines have the exactly same data. So in this case, you can see, oh, even machine C goes down, right? Machine A and machine B, because they have the exact same data with machine C, they can still work, right? So no data is lost. So machine A and machine B can still work. So they can still continue to serve the request from your clients, right? Okay, this is one technique, right? And the second technique, so there are multiple other techniques, but I can give you another example, which is read, right? So it's a disk management technique, which is basically what it means is machine A, machine B, and machine C, they don't store the exact same data, but they store different data. However, the data from one machine can be computed from other machines. Okay, so let's say just one example. Okay, let's say you store some data to machine A, machine B. Oh, let's say you store the friend data or some other data, right? So let's say the data could be represented as numbers. Okay, so let's say now you're writing two numbers into the system, number 1 and number 2. It must be written to the system. Okay, so let's say number 1 is written to machine A, number B is written to machine number 2 is written to machine B. Okay, so let's say number 1 is written to machine A, number 2 is written to machine B. So for machine C, you store the sum of these two numbers, which is 3. So here in machine C, on machine C, you don't store the original data that the user originally writes, but you write some redundancy data which is computed from the original data. In this case, it's 1 plus 2, which is 3. So 1 and 2 are the actual user data, but 3 is not the actual user data, okay? So now in this case, you can see, oh, let's say machine C goes down, okay? Nothing will go wrong because the original data is still on machine A and machine B. So next time when you read the data, 1 and 2 is still available. So you still get the same data, okay? But what if machine B goes down? Okay, if machine B goes down, yes, indeed, the original user data 2 is lost. You don't have it anymore in the system. However, because the data from machine C is a sum of machine A's data and machine B's data, so you can just recalculate machine B's data based on machine A and machine C. In this case, machine B's data is machine C's data minus machine A's data. So 3 minus 1 is 2, right? So in this case, even machine B goes down, machine A and machine C, they are still online. So you can still recompute the machine B's data. In this case, data is also not lost, right? So the user can still read the previous data they write, right? So, okay. So this is another technique which is used very commonly in RAID system, okay? Okay, now you can see all the 3 machines, they actually serve the user's request. They are always active, right? There's no standby machine. So that's why this is called active mode. While the previous one, machine D and machine E, they don't serve the request from the user, or they don't even store any data, right? So they are just a standby here. Only when something goes wrong, it kicks off. So one machine will be kicked into the active group, okay? So these are the 2 modes to achieve, to use multiple machines to host the service and the feature, right? Okay, so this is availability. Okay, so this is non-functional characteristic 1, which is availability. Okay, in next session, we are going to talk about the next characteristic, which is scalability. So, see you in next session. Bye.